The application level scripting, from the viewpoint of the coding level, the beauty of functional programming lies its own use of passing function as argument. This allows us to inject any function to the argument and offers incredible flexibility. The fact that functional programming is useful in every way is historically proven. Applying this same concept not only at the coding level, but also the application level, what happened? Typically, when using a graphical user interface, user enter values like their name or birth year or addresses. Now imagine if we let users enter the script they want to perform, like passing function as argument in functional programming. This could give us even more flexibility and possibilities. So, yeah. This idea or architecture pattern is not new and is a well-known technique. Actually, there are famous embedded languages, such as Lua, for example, which I believe are used by many people. However, throughout my 20 years career in system development, I have to admit that I haven't often seen systems that efficiently utilize application-level scripting. It's rare for me to encounter such system. Of course, this is within the scope of my own experience. But even if general technical literature or online resources, the application-level scripting does not seem to be a technique commonly employed, at least not frequently. Despite this, I firmly believe that application-level scripting is an excellent method and should be more widely used. That is the key message I wish to convey today. Okay. Let's explore why ALS is not widely adopted, despite being a well-known method. Maybe one possible reason is that people think it costs a lot to implement a new language. But no, I'd urge that this is not the case. The reason is that the language design for ALS doesn't need to be a general purpose language, which means they don't require complex syntax, fast compiler, or beautiful standard libraries. The simple interpreter is enough. Furthermore, the using Scala and its excellent libraries can significantly reduce the implementation cost. Okay, now I'd like to introduce my Flappy language. The Flappy is a small language for ALS to be integrated with Scala. Its syntax is similar to core OCaml. And the key feature is that all numbers are represented as a big decimal, which is essential for financial application. It has a parser built with cat parse library in just 500 lines, and interpreter of the same length, very small. And here it looks like that. Here is a variable d in a let-in expression, and d is a list of the to record field k and field v. And the variable d will be mapped on a nameless function extracting the field v, and mk string will be concat the string with the space separator and result the hello world like this. This is a Flappy language example. The implementation, I implemented this language in just 3 days. It's about the level of difficulty you'd expect for university student project. In other words, Scala is such a powerful language. And this language can be used within Scala, like this. First, create an instance of the language and an environment and an input. The environment variable contains the variable x binding 1, variable y binding 2. Then by calling the first and eval with m function, you will receive a value wrapped in try along with the applet environment. In this case, the new variable z was added. Very easy to use within Scala. This is one of the reasons I didn't use a Lua, which is written in C. Okay, so here's an overview. What was necessary and what wasn't? The features required for an LLS language are really minimal. First, idioms for risk operation are essential. Without them, writing business logic will be challenging. And we achieved this idiom by calling Scala's native map and for-left function through a foreign function interface. I didn't implement it in the Flappy language. Also, recursive function was needed for writing somewhat complex logic. But I haven't implemented the tail call optimization. Sorry, it's quite challenging for me. And record types compatible with JSON and a built-in eval function were also necessary. On the other hand, there are many features that Flappy still doesn't have. The loop syntax, discriminated union, the class definition, namespace are all absent. And there are no static type checks. While these features would nice to have, but they weren't essential. I have applied Flappy to various use cases and found that these features were not essential. Okay, now let's consider a second reason why ALS might not be widely adopted. Some people might think that even if the language implementation cost is lower, the use case where ALS can be effectively utilized is rare. Indeed, application user could be required to write small programs, which seems challenging for those without programming knowledge. Yes, that's true. But users like system administrators who have programming skills do appear in many system workflows. Moreover, in systems where developers are the users, the barrier to write script became even lower. I will introduce 3 use cases where I have successfully applied ALS. The first example involving calculating service charges. In a system designed to process orders, it was necessary to automatically calculate and display service charges that depend on the customer and the product. While there were the basic rules for calculating these charges, there are many variations depending on the who was buying and what service was provided. Attempting to handle these with a unified function would have required a lot of branching flags, leading an overly complex and unmanageable implementation. This is where Flappy came in. For each combination of customer and product, we create a Flappy script and store it in a database. The input for the script is which customer was buying and what service was provided. And the output is, of course, the service charge. These scripts were quite small and easy to maintain. The workflow proceeds as follows. When the sales user had a new customer or change in the contract, they would require the system administrator, they would request the system administrator to update the charge calculation. Upon receiving the request, the system administrator would add or modify the Flappy script. Then the user enters the detail of the individual services provided to a customer. The system executes the corresponding Flappy script with that input and displaying the calculated service charge. We implemented over 20 patterns of charge calculation in Flappy, and it worked correctly. As a result, salespeople no longer have to worry about whether the system could quickly support new rules of charge calculation. And this is a big point. Scala source code is clean because it's independent from the data. Okay, next example is a reporting system. In this system, Scala data need to be, in this system, sales data need to be processed in various ways to generate report to customers or managers. To accommodate this, users were allowed to freely select the item to construct their reports. However, there were over 100 items to choose from, and some of them have a customer-specific logic. For instance, some additional information. Anyway, the hard coding this kind of customer-dependent rules into the source code was impractical. Therefore, we decided to utilize Flappy script. The system administrator could create any new item by saving an item name along with a Flappy script through a system-provided interface. A Flappy script is a small program that takes a sale date and return new item data. For example, the script could generate the total price by multiplying the unit price, the sales quantity. In practice, the 109 items were written in Flappy on the reporting system. This approach allowed for quick implementation of customer-dependent items, offering users increased flexibility. Also, it removed the coupling between data and source code from the system also. Okay, the last example is about creating the job scheduler that can run Flappy script. Let me explain the background. In one company, they had many small systems that all worked in a similar way. This system would take information from database and then elaborate it in specific ways. What's interesting is that through they were trying to achieve similar goals, the technologies used variety depending on the developer and the urgency of the situation at that time. Some systems use shell script, and some of them use Scala or .NET. Another problem is that a few of these systems were missing important functions like saving execution history or saving error details like stack trace. This laid a big risk to higher operation cost. Therefore, I created a generic job scheduler that could run the Flappy script. The job could be created, edited, and deleted from a web interface, which also provide execution history and showing error details. Various extension functions prepared on the job scheduler, executing SQL statement, creating CSV and Excel files, sending emails, SFTP transmission were available on the Flappy side script through a filing function interface. The GUI looks like this. Okay, the left side is Flappy script, and the right side eval result. Okay, so As we supported various requirements, currently the 45 scripts are running on this job scheduler. This includes, many functions. Yeah. And the Microsoft, the report generated by Microsoft report service was migrated to Flappy script. Yeah. It reduced massive implementation cost. Okay. I introduced 3 use cases. Let me consider when is it advisable to consider ALS in general. I suppose if you want to avoid strong tie between data and source code during development, it would be good timing to consider ALS. The ALS can be the intermediate level between them and helpful decoupling. And another case, if you find a pattern workflow in different systems, chances are this system could be the unified system by single low-code system like Java scheduler. The ALS can be the low-code part that users can develop. The infrastructure part can be implemented in general purpose language like Scala. Okay, let me summarize the presentation. The ALS makes system flexible like functional programming. And the language implementation cost for ALS is very small. Don't worry about that. There are many use cases we can apply ASL effectively, efficiency. So the result, ALS and homemade language pattern should be more widely used. Thank you for your kind attention.